we're going to conclude your biostimulants session with some individual breakdown of costs per element or per group of elements as we mix them. Once again, we're not representing a particular product, we're not promoting anything in particular, we're just giving you groups or generic categories of plant elements and nutrients and other amendments that you can acquire in your local areas and mix. And I want to start out with the most expensive additive that we have to our biostimulant mixture, and it is a tank buffer. If you want the names of any of these individual products that we use, welcome you to call us, email us, and we will gladly share this information. It's not proprietary. We have a supplier that'll send this stuff anywhere in the world, but right now I'm not promoting that. I'm just trying to teach anyone that's interested in how to save money with their biostimulant mix. We start with the tank buffer, and the reason we start with this cost $37.50 for a 200-gallon mixture. It takes 17 pounds of this, and I'm going to put on my glove. I hope you use a latex glove when you handle any of these products, not because they're poisonous or toxic, but because they are caustic. They have a different pH and they'll burn. I want to show you this. This is a powdery-like substance, and as you can see, it has a crystalline sort of appearance, and I'm going to just dump that out right there, get it out of the way, and it expands the pH window from 2 to 10. And as you'll see from the graphic that we have here, there's only a very narrow range that these nutrients can be absorbed by the tree. And in order for us to make absorption more comprehensive, more complete, and give you and your customer more bang for their buck, we are using this this tank buffer to expand that window and open it up just as wide as we can. One other note in passing. Most of the city water sources anywhere in this country are now using chemicals in potable water that take the pH as high as 10 or 11. If you're close to the source, downtown for example, it could be as high as 11, 11 and a half. If the pH is that high, and if you choose to use biostimulant additives that include living microbes, you're going to kill them. They will not live in that type of environment, and so the tank buffer, although it's expensive, is a very important aspect of your biostimulant mixture. Now, for those of you that are still using chemical fertilization, let's understand that you have discussed this with the owners of the property, and they understand that these chemicals have certain downside risks, and you can very cheaply apply a nitrogen, potassium, phosphorus chemical mixture that what we call macro elements, and they include nitrogen, potassium, phosphorus, calcium, magnesium, and sulfur. We can replace these by using a biostimulant mixture that has humates, and these humates contain virtually the same sort of combination of elements, but they are derived from ancient deposits in the ground that are harvested, and in order to get the humic, omic, and fulvic acid from them, they dribble certain chemicals over these deposits, and it yields these extracts. And these extracts are called humates. And when you start down the road of biostimulants, you need to start with humates. And you can acquire these virtually anywhere under a large number of brand names. And this one, for example, cost $18 per gallon. It's $9 per tank for a 200-gallon tank. $9 to put this in, as opposed to our chemical additive, which was $12 for 2 quarts. And so you see we're really in the same ballpark economically. It's just a matter of what you and your customer have decided is the most important elements of the fertilization program. All right, we're talking about the 16 mineral elements that come from the soil that supply, and the bulk of them come from micro elements. It's kind of a lengthy list, but they include chlorine, iron, manganese, molybdenum, boron, zinc, copper, sodium, nickel, and selenium. And these can be acquired with a chemical mixture that usually is $8.75 for 2 quarts, and that will be enough for 200 gallons. And these complements of minerals are what are essential for a balance in the soil that we've been talking about, where we balance, then measure what we've done, and then learn from the results. And so micro elements is one. Now, if you're going to go organic and you're going to go natural, which is what most of our customers have decided, we use kelp. You can acquire most of your micro elements by using a kelp mixture. This is from the ocean, and kelp is actually the trees that grow in the ocean. They're very tall. They can grow hundreds of feet, and these plants are harvested from the ocean, and there's an extract taken from them. And most people don't realize that most all of the topsoil and erosion on the planet ends up in the ocean, and we have very fertile conditions there, and so we can get most of the micro elements in kelp for almost the same cost. These cost $8 per gallon, and it takes 1 gallon of this for a 200-gallon mixture, and so you have to use a little bit more, but the costs are roughly comparable. And in addition to your mineral elements, you can get the kelp, growth hormones, sugar, enzymes, and amino acids. Now, in our standard biostimulant mixture, if there is such a thing as a standard, almost everything we do for our customers is customized based on their individual needs. But as I mentioned, kelp, in addition to your micro elements, has growth hormone, sugars, enzymes, and amino acids. We add to that a root stimulant. Now, this is a synthetic derivative. There's nothing really very organic about it. If you've got organic root stimulants, it would be so expensive that you couldn't afford it. So there is a synthetic derivative that is used, and in almost all of the urban soils that you're going to deal with, they are geotechnical mixtures of silt, clay, sand. You might be lucky enough to have some topsoil in some of these, but most of the time you do not. And as a result, root stimulants are going to be required. You can put these root stimulants in virtually any mixture because they are synthetic. They don't involve living microbes like some of our other mixtures do, and they can be mixed with these chemical or organic mixtures successfully, and we would strongly recommend that you do. Now, I'm going to preview, we're going to get more into the soil microbes in our next inoculation to populate segment, but the microbes are a slightly different animal, and I want to point those out to you right now, because in order to add these to our biostimulant mixture, you have to realize that there are living organisms within this mixture, and because they're living, they have to be introduced into an environment that supports their growth and maintenance, which means, just like anything else that's alive, they have to have food, water, air, energy. And so you're finding that the cost is about the same. Your application methods are going to be adjusted modestly so that, for example, you don't leave the tank in the sun to heat beyond 140 degrees, that you make sure the water in the tank is buffered so that its pH is not out of the range of what these elements could be absorbed in. And once you observe those particular elements, those rules for applying biostimulants, then you've got a program that can be varied according to whatever the customer can afford and what is demanded by the job at the time. We've talked about what is demanded on these jobs, and the easiest way for you to track these details is with our protocol. The 10 steps of the protocol gives you a chance to record this information, and it makes it possible for you and the customer to recognize success. It's very important that you do this and agree on what you're looking for in the designed ecosystem. Are you looking for additional rooting? Are you looking for topsoil formation? In the 3 previous tree preservation actions, where we did root collar excavation, aeration and decompaction, and topsoil formation, we have prepared the way for air spaces large and small, the pore space and density of the soil. We have given through erosion control and through topsoil formations, establishing the topsoil skirts around each tree, the environment for air and water.